we begin with our video, we would like to make a small request. Kindly subscribe to our channel and like the video if it helps you, and also share it with your friends who may benefit from the same. In this video, we'll be showing how to simulate a three level three phase inverter. So first we'll need a DC voltage source, and we'll need an RLC branch. There we go. And now we'll also need an inverter. So MATLAB has ready-made models of inverters, so let's search for three-phase three-level inverter. There we go. It's a bridge inverter. So a bridge inverter, and we'll have to rotate this and flip the block because we'll need to connect positive to the positive terminal and then the negative to the negative terminal, and there's a neutral connection as well, which I will show you how to connect to. So now we also need a three-phase RLC VI measurement block. So this will basically measure the voltages. Now we need kind of ground, so we'll take a ground and let's set the DC voltage as 600 volts, and let's make the RLC branch into an RC branch. So but we'll also need an three-phase parallel RLC branch for the load, so which is three-phase. So now we'll make the RLC branch into RC and set the resistance and capacitance values, and we could just copy paste this because we'll need two of them. So copy paste and connect the two and connect to the positive and negative terminal of the DC voltage, and we should also connect the middle of the wire to the neutral. Yeah, that's the configuration on the DC side, and connect the ABC respectively. And now it's time to make the let's take the ground close, and we also need three sine wave blocks. So to make a three-level PWM gating pulse, so take three sine waves, and we're supposed to change the frequency to 50 Hertz and let the amplitude be 1, and the phase for the first sine wave has to be 0. The phase angle is 0, but the phase angle for the second will be 120. So since it's in radians, it will be 2 pi, which is 360 by 3, which is 120. So it'll be 2 pi by 3. So now let's take the second sine wave block and make it 2 pi by 3. The frequency remains the same. Third one will be 240, so it will actually be 4 pi by 3. So now let's move to the other side, and now we'll have to set the configuration of the inverter. So we'll have to make it IGBT diode. So let's make it IGBT diode. Now let's go ahead and measure. So we'll need to measure it from face to face. So once this is done, we'll make the load a purely resistive load. So we'll set the load to be 1000 ohms, and let's connect the end of the load to the ground. Now coming back to the generation of a three-level PWM generator, so you'll need to provide a reference to the PWM generator. So this is basically three sine waves that we had previously set, and we need to connect it to a mux that will combine the three sine waves, and we'll need a PWM generator. So let's go and find a three-level PWM generator. It's three-level, and now connecting this three-level to the reference has to be connected. But before that, we need to change the carrier frequency. So let's change this into 27 into 50 into 3. Now we need to give the inverter a gating pulse. So once this is done, we need to visualize our outputs. So let's take a scope and let's make the scope into a split screen. So click on the scope and go to view, then you go to layout and make it and after that we also need a GUI block, and let's simulate. So as you can see, the simulation takes it's pretty slow, it takes quite a while. So clicking on the scope, we get the output. So if you zoom in, so as you guys can see, the obtained output is in fact a 3-level inverted output, whereas it's become from AC to DC. Let me just zoom in again. Yeah, so that's how a 3-level output is supposed to come. Do check out our other video where we've done for single phase inverter. We've provided a filter, an LC filter, which makes the wave sinusoidal. So you can have a look at that as well. And if you like the video, kindly like, as we mentioned before. Subscribe to our channel as it really helps us keep going. And do check out our other videos. Thank you so much.